Hello and welcome to Module 24. So in this module we are going to talk about the technologies and the protocols and how can they be used to secure a network. So we'll talk about the monitoring common protocols that are available and the different types of technologies that are out there. Alright, so again, make sure that you have your Microsoft Word ready to take notes. All right, so let's begin with the Syslog servers and the NTP servers, the Network Time Protocol server. The Syslog server is mainly used, please write that down. The Syslog server is used for logging event messages from the network devices and endpoints. So you need, every time that anything happens on the network, an interface went down, you're taking a router and LAN went out, something went wrong. Every time you are sending information to a server, and the server keeps track of it. It keeps just listing, like the event viewer on your computer keeps track of all the events that happens on your PC. The Syslog server, system log server, keeps track of all the events that happens on the network. Routers can be sending information to it, switches and so on, and even end devices as well. And remember, please write that down. Also, it's the centralization of log collections that help make security monitoring practical. So they operate at port 514, UDP port 514. All right, so that's the Syslog server, and of course, from the Syslog server, hackers can go in there and can actually find out where some of the events that happened on the networks, when it happened, and what happened, and they can take advantage of that. So you want to, make sure that hackers don't have access to the Syslog server and make sure you can protect them from. Please write these 2 bullet points down. Prevent them from accessing the Syslog server. So they can have something in place where they'll prevent your routers or switches or the end devices from sending information to the Syslog server. So we need to know that. And also, all Syslog events are timestamped. So this way you'll know which one's the latest and which one's the latest information that's being sent to the Syslog server. So when you are evaluating it, to make sure that all the devices are in sync in terms of time, there is a local network timing server that everybody needs to connect to, and they'll sync their time, the clocks, with it. So now anytime you send an event, it is time stamped and everybody is in sync and they know that this is the latest and the greatest event that's been, or if there's any old events they can delete. So when you are evaluating all the information in the Syslog server, you can go by the time and figure out what is the latest information was sent by this router, for example. All right, so please write down this statement and this statement, the last 3 bullet points for the network timing protocol. Right, so the NTP is used to synchronize all the devices that are in the network. And threat actors, of course, can take advantage of it. Now there is also the DNS, the old DNS. We can use the DNS to communicate with command and control servers. So to exfiltrate data in traffic, disguise it as normal DNS. So you can hide the traffic, take data out, and be sent. So if you send something like this into the query, you're trying to request something so you get some information back from the DNS server, you got to protect against queries for just bogus data, right? So please write these down for NDS. A malware could encode stolen data into a subdomain portion of the DNS lookup. So where the name server is under control of the attacker, you can do that. A DNS lookup for a long string can be forwarded to nameservers.com. This would record a long string data and reply back to the malware with a coded response. So, and then you can figure out what the DNS server is trying, that coded response, figure what that out. So you have to be looking out for that. All right. So you want to make sure that, for example, you want to be able to look at for queries of something like this, where a long string of a record is trying to, where it doesn't exist, but a hacker did that purposely to get a response from the DNS server. So DNS proxy will log and analyze and detect these conditions. You may use the Cisco umbrella to detect such attacks to the DNS. Then you got the HTTP and HTTPS. HTTP is the guy who is responsible to transfer data, transfer web pages from the World Wide Web servers to your browsers. And that transfer is all in clear text. One of the common exploit in HTTP is something called inline frames. Inline frame injections is something that where the HTTP server will go to, when you are transferring a web page, some information from a different server will be also transferred to your web page as well. So write that down. When an iframe loads, malware is downloaded frequently from a different URL, from a different location. Okay, so you've got to watch out for this HTTP. You may use Cisco Web Reputation Filtering to detect when a website attempts to send information. So please write that down about iframes. That's second bullet point, and the third bullet point. Right? So you want to make sure. So one solution is, of course, to use the HTTPS and make sure that only communicate with HTTP secure. And HTTP secure uses SSL to connect. So this way you avoid all, no altered, to adjust the alteration of confidential data. So using HTTPS, all your data will be encrypted and then sent on its way to its destination, and this guy will decrypt the data for you. Much easier. The only problem is, of course, if you want to, as a system administrator, you want to be able to view the data, you will not be able to, because all the data that's traversing the network will be protected. So not only the hackers can't see the data, you can't see it either. So sometimes you maybe need to do that. So please write the following down so you understand how HTTPS works. So the way it works is, write these steps down. I know it's a long, but it's really, it helps you understand how HTTP security works. Because we understand, on I think a couple of modules ago, we discussed encryption, and now you understand how HTTP uses SSL to have a VPN connection between both of you. Anyway, so this is how it works. The user will request an HTTPS connection to the server. The server will send them a certificate. He'll have a private key, and generate a public key and give it to you. You will take that private key, encrypt the data, and you will create a symmetric key, encrypt that symmetric key, and send it to the server. The server will decrypt the symmetric key with its private key. So now both of you will have symmetric keys, and you'll be able to use the symmetric key to connect. Right? So you don't need anybody else to do that. So when you do HTTPS, this is exactly what happens. You send out a request, he'll send you a public key. You generate a symmetric key, and you send it to the server, encrypt it with your public key. And the only person that's going to be able to decrypt it is this guy, right? The server, with its private key, and you have connection. All right. Email email servers. Well, as we all know, the SMTP server is where you send data to be transferred to either an IMAP or a POP3 servers, right? So you always send your emails to a simple mail transfer protocol server, and you download your email from an IPOP or an IMAP. Well, this is where all the viruses are. In the IMAP, please write that down. IMAP and POP servers are typically used to download malwares. Typically, right? So you got to monitor these malwares from the ICMPO or POP server. So you have to have some sort of to monitor the system or to check them out for anti-malwares. ICMP, the Internet Control Messaging Protocol, is where this is the pinging that happens. Remember, we talked about that earlier in earlier modules. They can be used to identify, with the, ping suite, for example, can identify which hosts are connected to the network. You can find out and what type of ports that are open or things like that. So ICMP can be used tremendously, and you can also use. So please write that under ICMP. It can be used for exfiltration of data, because the concern of ICMP we use to either surveil or deny services. We can use it from inside the network, is sometimes overlooked. So sometimes we ignore, because this is really a lot of times, a lot of the attacks happens from the inside. We usually deny, overlook it, not necessarily deny it. And please also write that last bullet point. There are exploit kits that will allow you to use ICMP packets and to hide malware in it. That's called ICMP tunneling. And so when that ICMP packet is traversing across the network, sniffers will allow it to go through because it looks like an ICMP packet, but on the other hand, inside it is really a malware. All right, let's take a look at some security technology that is out there. Then we have ACLs. ACLs, the access control lists, are typically used to either permit or deny data from going in. This is really a firewall. That's what ACLs. ACL routers allow you to configure the rules, such as these, as we've discussed in previous courses, and we'll have some examples to do in class activities, where you will configure the router to either permit or deny packets from going through. And you can control ICMP packet using those ACL rules. So, for example, this will permit an ICMP pinging or any ICMP packet from any source to any destination. Echo reply, meaning you can reply to your ping commands. Okay, so that's a typical, and this one allows the pinging, for example. This ICMP protocol, this will permit anybody from this network, 192.168.1.0, you can ping, echo means pinging, to anybody. So you can write rules like this on the routers, and then you can apply it on the incoming or outgoing interfaces. So attackers can determine the IP addresses, the protocols, and the port numbers that are allowed. So please write that down. So this is a flow within the ACLs. If somebody can get into your configuration file on the router, there will be or the firewall will be able to find out which packets are permitted and which packets are not. And then you can, of course, you can create packets and spoof the IP address, the protocols. So this way you'll be allowed, you'll be permitted, right? So knowing that, please write down that the Cisco next generation firewalls and advanced malware protection and email and web content appliances will be able to address some of these issues. Okay, then we got NATPat. Well, the reason we have NAT is anybody that's inside the network that has a private IP address, when he needs to access the internet or outside his network, he has to go to the router that is NAT enabled, will be given a public IP address, a global IP address, to access the internet, and when you come back, it will be translated back in. Now, PAT, port address translation, is using one IP address for multiple addresses that are inside to access the internet. Now, that could be cumbersome, going in and out. If somebody can attack NAT and find out where the addresses are, what's going in and out, that could be an issue. Who's being translated, who's not. They can find out, the inside IP addresses of your network. Okay? So, please write these down, the last two bullet points. If the port address translation is in effect, which meaning you're only using one IP addresses, the public IP address has been configured on your local router to allow multiple IP addresses to get out, multiple inside IP addresses to get out, and you differentiate them by using the ports, the source ports that they are transmitting. That could be an issue. It could be difficult to log the specific network device and where it's going. So you would use Cisco NetFlow to figure out, exactly who's who. Encryption, encapsulation, and tunneling. So encryption, of course, we already know encryption is very important to make sure that to protect the confidentiality of the data. So no eavesdropping on the data will happen. But also the problem is you can't see it, like I said earlier. You won't be able to figure out. And so if a criminal wants to go in and they'll encrypt the data, create a VPN, for example, inside the network, and they'll be able to connect, and you won't be able to see it either as a system administrator, and you can decipher if that data that is flowing in the network is malware or not, or is it attack or is it not. So encryption is part of VPN technologies, and so you have to be able to make, what are you going to do? Are you going to allow unencrypted data, non-VPN data inside the network or not? So it all depends on what you're going. It all depends on how secure and how big your enterprise network is. Okay? Peer-to-peer networking is a really big, huge issues in terms of administrators. Peer-to-peer, directly connected, no servers, and, you encrypt data you took from one device to another device. So there are three types. Please write these down in peer-to-peer network applications. File sharing. A lot of the internet, when you download and upload files from one server to another, in the old days they used to share movies, books, songs illegally, and there are peer-to-peer servers. And they're encrypted data, and nobody will be able to figure out, who's doing what. You could do processor sharing, so you can allow other devices to use your, if you have 8 core CPUs, you may allow other people to use your CPU power to process data for you. And instant messaging. Right, so write these down. Bitcoin, for example, and BitTorrent is a peer-to-peer file sharing. BitTorrent is what they do to allow so you can't even be detected. They send from multiple servers. Let's say half of the file will be given here, and the other half from a different server. So it's very difficult to detect. And when you get it, you combine it together. So bit by bit, you can actually have your file being downloaded from different places, and it's almost impossible to download. You can download illegal files and things like that. Right? So remember, write that last statement down too. File sharing P2P application should not be allowed on the corporate network. Okay, so the way to do that is you want to have firewall protections. All right, so instant messaging, of course, is the same thing. You're probably going to need that. We discussed and we talked about processor sharing. You may need to do that. It depends. If you have way too much, if you have a database that needs more power, you can connect it and ask another server to allow it to use its CPU power. Bitcoin does that a lot. right? Allow multiple devices to process data. All right, Tor. Tor is, please write that down, is a software platform that allows P2P hosts to function on the internet routers. So you can get a Tor browser, web browser, and it will allow you to connect to any device on the internet. Well, they call it the dark internet. And every time you connect from one to another, you are encrypted. So it works like you're peeling away. It's like a layers of onion. So please write that first in terms of Tor. The first bullet point. So when you traverses the network, the layers contain encrypted data to the next hop, from one hop to the other. So you will never be able to figure out where your data, who's doing what, because every time you connect from one hop to another, the data is encrypted differently, and you just only the two guys that are connected to each other will be able to peel and view the data. So it's almost impossible to figure out what you're doing. So if you are using Tor web browser, and you can use a specific, I think DuckDuckGo is the search engine that you may use with Tor, you can almost search for anything and you will never be detected, and your data will never be captured by anyone. So Tor is widely used for criminals on the darknet. The darknet meaning where you can actually search for illegal stuff and download something that is unethical or illegal. And it can be used to communicate for malware, for command and control as well, right? So please write that down. And as the destination IP addresses of Tor is confused by encryption with only the next hop knowing, so you can avoid blacklists. They can never blacklist you. They'll never know who you are because you are constantly, the traffic is changed from one hop to another. So it's very, very difficult to detect if you are operating with Tor. Load balancing is with DNS delegation. This is to allow you to send data to multiple devices so you can ease to prevent the overwhelming of the traffic, so you're not inundated with so much traffic, so you can have multiple DNS server working for you at the same time, for example, right? What else do you need to know? That's probably okay. So that ends the module 24. Please write those notes down that I asked you to and upload them. And I will see you